really 2.3 is possibly the single most important section in this course. I'm just going to go ahead and say it is the single most important section in this course, because it's how do you solve any linear equation. And those same steps are used, I mean, countless times on every single test we take, you will use these skills. Because even when we get to later problems and it's like solve, square root of x plus 3 equals x minus 2, or, just even equals 3 or something. The first step is new, chapter 7, chapter 8, whatever chapter that is. And then every step after that is section 2.3, right? So every time we go on to a future section, it's like, okay, the first two steps is chapter 6, and then it's 2.3. First new step is chapter 5, the rest of the problem is 2.3. So get really comfortable with this. I'm a big picture guy, so I'm going to tell you some big picture ideas, like a general strategy. And what helps me when writing a general strategy is, as I'm explaining the steps, I like to have an example problem going here, so you can see, do step 1, what does step 1 look like? So that's the way I'm going to write the notes. So this is titled Solving Linear Equations. Very straightforward. Okay, but now we're not holding anything back. There's no secrets anymore. We're doing every type of linear equation. Alright, so the first step in our general strategy, and I do a lot of general strategies, these are my own versions, my own wording, and this is how I see it. So first, we get rid of all parentheses. Get rid of all parentheses. In parentheses, we distribute. Right. Here's an example problem. So that's what a problem in 2.3 is going to look like. So step 1 would take us from here to here, and we would distribute this -4, not just 4. I purposely picked one that had distributing the negative, so that would be highlighted. We would distribute this -4n, and we get 5x minus 4x minus 36 equals 2x minus 3. First step. Every time we see any equation, we say all those parentheses are unnecessary. Let's get rid of all. Okay. Step 2 is combine all the like terms. So what that's going to leave us with is one group of x's plus numbers equals one group of x's plus numbers. So here our like terms are, we've got 5x and -4x, that's it. Right, so that gives us x, 1x, minus 36 equals 2x minus 3. And every time after we distribute and combine like terms, that's what a linear equation is going to look like. That's the only linear equation you need to know how to solve. Okay, step 3 is put all the variables to one side and all the numbers to the other. So this was x minus 36. You don't need to copy it a second time. I just, because it's from the last page, I'm copying it. So step 3 would be this. I'd say, okay, which side do I want to get things on? Doesn't matter. Which side do you want to put it Okay, well, for the sake of having another step, let's subtract 2x from both sides, so this cancels. Which means since I put all the variables on the left, I'm gonna put all the numbers on the right. So I'm gonna add, I'm gonna add 36 to both sides. So this cancels. So what that gives me is x minus 2x is negative x equals negative 3 plus 36 is 33. And the last step, step 4, is divide by the coefficient of x. Alright, and I specifically say unless there's exactly positive 1. Okay, because this is not positive 1, so what do we divide by here? Negative 1. That's it. Divide by negative 1, we're done. Now, whoops. I write one extra step in here, right? So we get x equals negative 33. That was our step 4, our little 4 general step process. Step 5 is plug in your answer. Right? And this is that resilience and that hard work and that effort that means the difference between you getting an A or a B, you getting a B or a C, and I'm not going to grade you on whether or not you did this, but you're going to catch mistakes. And even if you catch one mistake on each test, that's test points back in your pocket from a stupid mistake that effort added to your test score. So you could go back to the first one, you could say 5x minus 4, x plus 9 equals 2x minus 3, and each time there was an x, I'd write parentheses, and I'd say negative 33, negative 33, negative 33. If you have a calculator, use the calculator, right? 5 times negative 33, that'd be negative 165, minus 4 times, we can add these together, and we get negative 24 equals negative 66 minus 3. Multiplying first, negative 165 plus 96 equals negative 69. Adding these together, negative 69 equals negative 69. Alright, we checked the 100% sure votes. Okay, and that's one of those things that you can use the calculator for. You can check it at the end of the test, and then you walk out of the test knowing you got it right. Or, very unlikely, you made lots of mistakes that all worked out perfectly. Alright, sound good? Well, I'm just going to do a couple examples, and then I'm going to show you a common trick. But that's really the central example, okay? Let's do one more example of real time. Okay, so here's an example, number 4. Right? And when we're starting at the beginning, it's going to be shorter, so there's going to be less steps. So for example, starting with this problem 4, there's no parentheses, right? You don't have that step in there, and as you build up difficulty, as you go from problem 4 to problem 70, they get longer. Okay, so first step, parentheses, done. What's the next step? Yeah, let's combine like terms. And bam, all of a sudden we've got that same linear equation that we've got all the time. I'm going to rewrite the right side just because it makes me more comfortable as x is first. Absolutely, you don't have to do that. I like it always looking like this. Okay, you don't have to do that. But I know every single linear equation boils down to that. X's plus numbers equals x's plus numbers. So, how would we solve it? Perfect. Wait.
To both sides.
If we add a negative 7, that would become negative 14.
No, they're like adding 7.
Adding positive 7, yeah, so just add 7x, exactly, add 7x. Perfect, so yeah, be careful with the negatives. And so that cancels, we get 5 plus 7, 12x plus 64 is 40. And then, somebody other than Isabel, she's got this.
Subtract 64?
Yeah, subtract 64. So now all the numbers are on the right side. Subtract 64. That's gone. We got 12x equals negative 24. And then last step.
Divide by 12x.
Yeah, divide by 12 because that's the coefficient that's being multiplied times x. And so we get x equals negative 2. Alright, so those same steps every time. Let's do one more hard one, and then I'm going to show you a common trick and the kind of loophole that comes up. Alright. So one more would look like this. 28 is 100 equals negative x minus 1 plus 4 x minus 6. Oh, is that right? 28, yeah, negative, okay. All right. First step, distribute what? Yeah, so first distribute this negative, and since it's a totally separate term, we could also, yeah, and I'm gonna circle the positive sign just so we never forget a sign. So yeah, so it's 100 equals negative x plus 1 plus 4x minus 24. And then combine like terms. So I always circle the sign before, so negative x and positive 4x, and then positive 1 and negative 24. So that's 100 equals, I'll always write my x's first, but you don't have to, 3x. 23, and oh, this was an easier problem, because there aren't even x's on the left. So that's nice, all of our x's are already on one side. So what do? Just add 23. Since all the x's are on the right, you don't need to put them on the left. It's totally okay to solve for them on the right. So we add 23, add 23. And so we get 123. Last step, yeah, divide by whatever's next to x. So we divide by 3, divide by 3, I have no idea, calculator, 41. Alright, so perfect. Alright, so there's two other things that come up in this section. That by far is going to be what every problem looks like. Moving forward, the rest of chapter 2 is going to be all using these same steps. So there's two other things that come up. One is, what if there's a bunch of fractions? There's a nice common trick. So I'll say, here's a common trick that I love. And this will show up on the test. You don't have to use it, but it's nice. Okay? And I'm going to call it getting rid of fractions. So you don't need to write this first part, but when we have 1/2 plus, 3/7, we have to find a common denominator to add those together. However, when we have 1/2 x plus 3/7 equals 1/7 x plus 1/2, what can we do now that instead of being an expression, it's an equation? So we can start doing that, but then we're still going to have to find that common denominator to put them together, and what a pain, fractions, put and multiply, common. There's a nice little shortcut trick, and I'll write it in words. I'm saying, what can we do, because it's an equation now? That'd be so sweet. Right, so what is that common denominator going to be?
14.
It will be 14. So the sweet thing that we can do now, because it's an equation, is we can multiply both sides of the equation by the common denominator, by 14. And because 14 is the common denominator, if we multiply 14 times 1/2, the 2 cancels out, no more fraction. 14 times a 7, 7 cancels out, no fraction. Times a 7 cancels out, no fraction. Times the half cancels out, no fraction. So if we multiply this entire equation by 14, immediately there are no more fractions. Okay, and life is so much easier. So that's the common trick. I'll show you. I'll give you an example. This is number 40 in your book. So z divided by 5 minus 1/2 equals z divided by 6. Okay, and right away, if people wanted to solve this, right, you could go about it in a couple different ways. Okay? The main thing would be I need to get all the variables on one side, all the numbers on the other, so I would subtract my z over 6 over here, and I would move my 1/2 over here. Then I would have to find the common denominator between z over 5 and z over 6 to add those together. That would be a pain. Then after that, I would have to divide by the coefficient, which is a fraction, and do a fraction divided by a fraction, and that would be a little bit of a pain. Okay? So what could you do? Right? And I mean, just if you wanted to see how to solve this, we could go, I don't want to trick you, I don't want to do it. Anyways, okay, so you could solve this with fractions. So I say multiply both sides of the equation by the common denominator, because we would multiply this entire side, we would be distributing it in. So really, I'm going to write in parentheses down here, really that means multiplying every term in the entire equation. Every term. That's the common mistake, is people will multiply all the terms with fractions, but if there was a +2 here, they would only multiply this one, and this one, and forget the 2 by accident. So when you multiply this side by a number, you distribute it in. So every term. Alright, so let's solve this equation using that method, and all of a sudden you'll see how much easier it looks. Alright, so if we have 40 is z over 5 minus 1/2 equals z over 6. What's a common denominator? It doesn't matter if it's the lowest, but the lowest would be nice. Is it? So 20 would be between 5 and 2, but 6 doesn't go to 20. So 30 would have all, yeah. So we could multiply both sides. So the LCD, which stands for the lowest or least, I hear both, but yeah, lowest common denominator. Denominator is equal to 30. So what we do is, we multiply both sides of this equation by 30, which is the same as multiplying every term by 30. And look what happens. What's 30 over 1 times z over 5? 6e, ooh, that's nice. Okay, what's 30 over 1 times 1/2? 15, ooh, that's nice. Equals, what's z over 6 times 30?
5z.
Ooh, that's nice. Look at that. That and that are the exact same equation. This one looks way easier to solve. This one looks a lot scarier. So anytime you see fractions, you can do this. Something that won't come up in this class, but might come up in future classes, is if you ever see a problem that's 0.23x minus 0.7 equals 0.01x minus 0.04, right? People would go about this hammer, 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 so rough and tumble. Well, it's a really elegant way to make this problem a lot easier right away. And what could we multiply by to make this way easier at the beginning? 10 would make it somewhat easier because that moved the decimal place 1, or times it by 100. If we multiply everything by 100 on both sides, look at this problem all of a sudden. Now the same problem becomes 23x minus 70 equals, you don't even need 1x, x minus 4. Whoa, way easier, exact same problem. Okay, and that's that freedom in math to elegantly go about a problem and be more fluid and open to these shortcuts and elegant methods rather than just follow step, right? But that takes some level of calm, some level of, losing that anxiety when you see a problem that, takes practice. But this is a great method any and every time you see fractions, and we're going to use this often in this class, okay? But I really wanted to highlight that. There's one last thing I want to bring up, and that's all solutions, no solutions. Okay, which might be a sore point for some people, but all solutions, no solutions is a kind of wonderful thing, I think. Okay, so and just to give you a quick example, what if I have x plus 3 equals x plus 5? What's our general step tell us? What should we do next? Yeah, we should minus. Yeah, minus 5, so we want to put all the x's on one side, all the numbers on the other. So let's, subtract 5, we're going to put all the numbers on the left, great. So we have x minus 2 equals x. So then we need to put all the x's on that side, so what do we do? Well, we already put the numbers on this side. Yeah, so subtract x. So we go minus x, and what in the heck? They canceled out from both sides, and we get negative 2 equals 0. Interesting. So, what that means is, the x's never matter. Think of it like what we talked about yesterday with the scale balancing. Okay? Oops. Okay, here's our scale balancing. Think of it like we had a bunch of x's on here and a number, and a bunch of x's and a number, and we took the x's away from both sides, and now there's no more x's. Okay? What that means is the scale was either always balanced or always not balanced. You added the same x's to both sides, so they really weren't even part of the equation. Every time all the variables disappear, you only have two choices. Either that statement is always true, no matter what x you plug in, because the x's didn't matter, or it's always false, no matter what x you plug in, okay? And so, if we have 0 equals negative 2, what x can I plug in to make that true? None, right? If I plug in x equals 1, there isn't even a place to plug in x equals 1. Is it a solution? No, x equals 1 isn't a solution, because that's not true, right? Is x equals 7 a solution? Well, let's plug it in. Is 0 equal to negative 2 now? No, plugging in anything for x doesn't change it. It's never going to be true. And a solution means when I plug in the number, it is true. So this is going to be no solution. Another way to write that, but I would say be careful, is a 0 with a slash through it, which is called the empty set. And I'll explain what that is in a second, but I want to explicitly write what we just learned, okay? So, this can be below, but at the end of the question, if all the variables cancel out, you only have two choices. The statement is always true, no matter what you plug in for x. So your answer is? You could write this in a lot of ways. You could write this as all solution, any solution. But the best way, since we're dealing with real numbers, is to write all real numbers. But I'm totally loose with the vocabulary. If you say all solutions, any solution, I'll give you credit. Okay, but all real numbers would be the best way to write it. And then I'm going to write 2 over here, but 2 would go right below that. And then I'll solve an equation like number 2. Okay. And number 2 is, one other way people write it is you could write it as identity. The reason is, so this would be something like x plus 3 equals x plus 3. So when you subtract the x's, you go minus x. Oh no, they all canceled out. 3 equals 3. The reason they call it identity is the whole thing of like 3 is obviously equal to itself. That's called the identity property. Obviously, I am the same person as myself, right? X plus 3 is obviously equal to x plus 3. So if you ever get, yeah. If you ever get something equal to itself, you could stop right there and just say that's the identity, or that's all real solutions. I like following it through until the variables cancel out. That's where I always go. Okay? So, possibility 2 is the statement is always false. No matter what you plug in for x. So there's no solution. And what you would write is either no solution, or you would write a slash through it, right? And so I gave you an example over here of a problem where you would write all real numbers. And I'll give you a quick example of no solution, even though that's right here is no solution. And one would look like 2x plus 5 equals 2x minus 5. You can't take the same thing and add 5 and then take the same thing and minus 5 and be in the same place, right? I can't stand here, walk 5 feet in that direction, walk 5 feet in that direction, and end up in the same place, right? That's impossible. So that's why it's no solution, but let's try it. Minus 2x minus 2x. Oh no, 5 equals negative 5. So immediately we say no solution. You don't need the quotation marks, I'm just doing that to show you that's the answer. Alright. That's where we'll stop, but I just really want to quickly tell you as a side note what the empty set is, because I think it's interesting. Whenever you say what is an answer, x equals 0 is an answer. Okay, x equals 2 is an answer, x equals -3 is an answer. So you could think of it like, I have a bag full of answers, because as we move forward in the class, problems will have 2 solutions or 3 solutions. So think of it as I have a bag of answers, and I go, okay, what's the answer to this problem? And I look in the bag, and I go, ooh, there's a wooden block in there with the number 3. So the answer to this problem is 3. Okay, or I take my bag of solutions, and I say, what's the answer to this problem? I open it up, and I take out the wooden block, go, ooh, 0. The answer to this problem is 0. When I write a 0 with a slash through it, that is not saying that 0, when plugged into the equation, works. What it means is, my bag of solutions, when I look at it, is completely empty. There are no solutions. I looked in my bag, and I just see a burlap sack with 0 wooden blocks in it. Okay, so this and this, totally different. So that's a mistake people make. It's a mistake I made on a math contest, and ended up, instead of being first, I got second, and I was really mad. I wrote that instead of 0, and I got docked like a point and then lost, and I was really angry. But they were right to do it. That means nothing, does not exist, completely empty, whereas 0 is a number, and that is a correct answer. I can plug in 0 and it works. Right? Yeah?
For the problem where you this is
Yeah, well, here, everybody can start. You can take a little break now. I like to do it after about 45, 50 minutes, an hour. So yeah, take a break, start working on 2.3. That's by far the most important section. And then we'll do 2.4 and 2.5 too also.